Review section, so section 2, part 2, and it's still reviewing some pre-calc and kind of algebra 2 topics, and this is, we're going to do exponential equations, logarithmic equations, and we're going to review how to use our graphing calculator, so we got a lot for today. All right, so it says solve the exponential and logarithmic equations, write answers in exact form. Okay, so exact form means that you're going to have square roots in them, you're going to have fractions, you might have logarithms left in the answer, and then you're also going to approximate to 3 decimal places. So we're going to do both, okay? So on the first one, I have log base 2 of x minus 1 minus log base 2 of 2x minus 1 equals 3. So if you remember, there's a rule that says if I have log of a minus log of b, I can combine those 2 logarithms. Do you remember the rule? What do? We divide. So we do a divided by b. All right, so when I get confused, I always think about the logs with base 10. Shh, guys. So if I do like log of 1,000 minus log of 10, do you guys know what log of 1,000 is? Do you guys remember? Yeah, it's 3. You just basically count the zeros. It's log base 10 of 1,000. So this is 3 minus 1, which should be 2. Is that the same as log of 1,000 divided by 10? In other words, log of 100? Is that also 2? Yeah, so if you get confused on the rules, think about the tens, like tens, thousands, hundreds, all those. Okay, so we're going to have log base 2 of x minus 1 over 2x minus 1 is all equal to 3. Okay, so once you get it in that form, you switch forms. Do you guys remember how to switch from logarithmic to exponential? No? Okay, so I always say the base of the logarithm, yep, is the base of the exponent. So this is going to be the base of our exponent. So we're going to start with 2. We raise it to the other side of the equation. So we're going to say 2 to the 3 is all equal to the part that's left without the log. So the x minus 1 over the 2x minus 1. We call that the argument, like log of something. Okay, so it looks like that. Then from there, we just continue. Okay, so now it's like algebra 1 almost. So 2 to the 3 is going to be 8. So we're going to have 8 is equal to x minus 1 over 2x minus 1. And we multiply that 2x minus 1 to the other side. So we get 8 times 2x minus 1 is equal to x minus 1. And we just solve it out. So we get 16x minus 8 is equal to x minus 1. So we have 15x is equal to 7. So x is equal to 7 over 15. Okay, that would be the exact answer. Okay, it's a fraction. We just leave it like that. So on the AP test, I always prefer the exact answer. But you can also round to 3 decimals. And you can round or you can truncate. So this decimal answer looks like this. It's 0.4666666, repeating. So you could have 0.467. That would be the rounded answer. That's the one I prefer, like a rounded. Well, I prefer the exact answer, but if I'm going to round, I would do that. And the other thing the AP test lets you do is truncate. Do you guys know what truncate means? Chop it off right there. And you could write that as your answer, 0.466. Doesn't that seem wrong? It seems wrong to me. I'm like, oh, don't build my bridges with those truncated answer. That's weird. All right, so the next one, so B. So I have natural log of e to the 5th plus natural log of x minus 1 is equal to 7. So you could combine using the multiplication rule, right? Natural log of a plus natural log of b is going to be natural log of a times b. But this one's actually easier if you notice something. Anybody see anything? Yeah, natural log of e to the 5th. The 5 can go to the front, and then it's times natural log of e. And natural log of e is 1, so all of that's equal to 5. So we have 5 added to natural log of x minus 1 is equal to 7. So then we can subtract that 5 over, so I get natural log of x minus 1 is equal to 2. Okay, now it's just a logarithmic equation. We have an invisible base. There's a base there. We don't see it. Do you guys remember what it is? Not 10. That would be the regular log, log. So it's ln.
Is it E?
It's e. It's the natural log, right? E is called the natural number, the natural base. So it's a little e is there. So if you need to rewrite it so that you see like log base e of x minus 1, that's totally fine. Right? So now we can see, oh, it's going to be e to the 2, right? So e to the 2 equals x minus 1. So x is going to be e squared added to 1. Okay, that would be the exact answer. Yeah, so I want exact answer and also rounded to 3 decimal places. So we're going to do e squared and then add it to 1 on our calculators. You guys all have your calculators out?
So do you want us to get all answers?
Yep. So it's e squared plus 1, which is approximately 8.389. Make sense? Okay, same idea on the next stuff. Do you need a calculator? Yeah, I might have one somewhere. Let me find it. All right, so part C. So try to switch forms. So switch from logarithmic to exponential. See if you remember. So it's 9 to the 1/2. So 3, yeah. So you're going to have 9 to the 1/2 equals x squared minus x plus 3. And 9 to the 1/2 was 3. So it's kind of nice when you subtract 3 from both sides, you do get 0 equals x squared minus x. And then we factor it out. So we have x times the quantity of x minus 1. Right, we pulled out the GCF. So we get x equals 0 and we get x equals 1. So I just do a quick check to make sure that you don't get the log of a negative number, because sometimes the answers that you get are what we call extraneous solutions, right? They're extra solutions that don't actually work in the original. So if you plug in 0, it's okay. You get log base 9 of 3, and that is equal to 1/2. And if you plug in 1, you also get log base 9 of 3, which is 1/2. Okay, so we're good. So we didn't get like log base 9 of negative 3 or anything like that. So both of those are answers. All right, so the next one, we got a lot of combining we can do. All right, put your computer away, please. So we have log 64 minus log of 32, so we're going to combine these two. We can combine them with division, so it's like 64 over 32. So we get log of 2. And then over here, we can combine as well. Or we could subtract the log of 5 over. It's up to you. It doesn't matter what we do. So let's say we go ahead and combine these ones as well. If we combine those, we'd have log of, and we multiply, so 5x minus 10. Right, do you guys see what rule I'm using? Like when you have 2 logs added, we can combine them with multiplication. So we have log of the quantity of 5x minus 10 equals log of 2. So don't overcomplicate things. What can we do here? Yeah, you can kind of just get rid of the logs, right? What we're really doing is we're doing 10 raised to both sides, like 10 raised to that side and 10 raised to that side, and the log base 10 and the 10 go away. That's kind of what we're doing, but really if you just kind of think about it logically, if you have log of 7 equals log of x, right? Doesn't 7 have to equal x? Does that make sense? You're taking the log of the same thing. So we're going to say 5x minus 10 is equal to 2. So 5x equals 12. So x is 12 divided by 5. Okay, so that's our exact answer. So if we wanted it rounded to 3 decimal places, yeah, I don't know why I put that in my calculator. I think I can do that in my head. 2.4. All right, we good? All right, so those were log equations. So let's try some exponential equations. Okay, so sometimes with exponential equations, you can get your bases so they're the same base. So do you guys see an example of one of those problems on E, F, G, or H? Yeah, do you guys see F? So you have 64 and 16. You could write those as like 4 to a power or even 2 to a power. You could get those to be the same. But we have an issue on part E. We can't get those to be the same. 3 and 18. Like 18 isn't 3 to some power, right? So in that case, we're going to have to use logarithms. And that's why logarithms were invented. They were invented to solve equations where we have x as an exponent. Okay, we need to be able to drop the x down. Logarithms drop x's. So what we're going to do is we're going to rewrite it in the other form. So this is exponential form. We can rewrite in logarithmic. So you could write log base 3 of 18 equals x minus 2. Does that make sense how I did that? Just writing in the other form. Do you guys see how it works? 3 to the x minus 2 equals 18. Okay, so if you prefer to always do it that way, that's totally fine. But there are other ways to do this problem. So really, I didn't have to do log base 3. I could have taken any log on both sides. So what I'll do a lot of times is I'll just do natural log on both sides. Okay, and the reason is because logarithms were invented to drop exponents. I just told you that. So what am I able to do with this exponent right here, this x minus 2? It can go to the front. Do you remember? You can pull it down. So it's going to look like x minus 2 times natural log of 3 equals natural log of 18. So we divide by natural log of 3. So natural log of 18 divided by natural log of 3. Don't say that's natural log of 6. It's not. And we can find that number. Okay, that's where the change of base thing comes from. Do you guys remember what the change of base formula, which said, like, if I have log base 3 of 18, it's natural log of 18 over natural log of 3. Or it's log of 18 over log of 3. Do you guys remember this from algebra 2? Or it's log base 7 of 18 over log base 7 of, it can be any base that you want. Whatever thing you started with here, right, you did it on both sides, you would end up dividing. That's where that comes from. That's why the change of base formula works the way it does. Okay, so we're to the point where we have natural log of 18, whoa, making me dizzy, divided by natural log of 3. So we're going to go ahead and find that. Oh, maybe I should do my exact form too. Oh, I did log for one of them and natural log for the other one. Can't do that. Got to keep it consistent. All right, so my exact form is x equals natural log of 18 over natural log of 3 added to 2. So you might see, like if you were taking the AP test, it might say this. You guys remember the change of base formula? That's going backwards with the change of base formula. You get it? All right, so when I add 2 to that number, it's approximately 4.631. So AP Calc is annoying sometimes because you got to remember all that stuff you learned in Algebra 2 and Pre-Calc as well. All right, so the next one we said was a little bit different because we don't have to do the natural log of both sides. You could, and you could simplify it out, you get the same answer. But in this case, if you recognize that 64 and 16 can be written as like 4 to a power or 2 to a power, it's going to be much easier. So it doesn't matter which one you do. Do you want to do 4 or 2? Let's do 4. So this is 4 cubed raised to the 3x minus 1. And this is 4 squared raised to the 4x plus 5. So we multiply our exponents in, just like if I had like x squared raised to the 5th, it would be x to the 10th, right? Same idea, we're multiplying our exponents. So I'm going to have 4 to the 9x minus 3, yeah?
I just don't understand how it changed from a natural log of 18 over natural log of 3 to a log.
Yeah, so this is using the change of base formula, which says like if I had log base 5 of 7, I could rewrite it as natural log of 7 over natural log of 5. There's like a little, before your calculator, like now your calculators, a lot of them have the log base button. Do you guys have that on your calculator?
Yeah,
So back when I first started teaching, there wasn't the log base button, and we always had to use that formula. So like students knew that one because they had to do it to get log base. To get log base, you usually hit math, and then it's way down at the bottom of math. So like this calculator is old enough that it doesn't have it. It would need to be updated. You see log base? If not, you got to put it in as natural log of 18 over natural log of 3 or log of 18 over. So kind of annoying. All right, so anyway, so I have 4 to the 9x minus 3, and I have 4 to the 8x plus 10. Did you guys have that? Okay, so again, we have 4 to some power equals 4 to a different power. Shouldn't those powers be equal to each other? Okay, do you guys know the operation that we're actually doing in order to get rid of those 4s? Yeah, we're doing like log base 4 and log base 4, and that way those are going away. So we're doing the same thing to both sides of the equation, which gets us to the point where we have 9x minus 3 has to equal 8x plus 10. Okay. So we get x is equal to 13. All right, making sense? Okay, so this next one, so I have 8e to the 3x minus 7 equals 12. I subtract the 3 over. I divide by 8. So 12 divided by 8, what's that reduced down to? So divide by 4. So 3 over 2. So now I have it set up so it's in exponential form. So it's like b to the x equals y, right? It's in that form. So a base to a power equals a number. So I can switch forms. I can switch from exponential to logarithmic. You can always resort back to that. Or you can just take natural log of both sides, right? And this one's particularly nice if you do natural log, because natural log and e cancel each other out, right? So does that mean that we just have 3x minus 7 hanging off in space? No, there's things that happen here. The power goes to the front, and then it's multiplied by natural log of e, which is 1, right? So it's not just like hanging off in the air. I've seen it all as a math teacher. I wouldn't say these things unless people had done that, right? All right, so we have natural log of 3 over 2, which is really kind of natural log of 3 minus natural log of 2, right? You could also see it that way. Tricky, tricky. All right, so we're going to add the 7 over and we're going to divide by 3. So our exact answer is going to look kind of funky. It's going to be natural log of 3 over 2 added to 7, all divided by 3. So let's get our decimal answer. So natural log of 3 over 2 in the parentheses, added to 7, hit enter, and then divide everything by 3. So you should get 2.468 for your rounded answer. Okay, feeling pretty good with these? All right, so logarithms are pretty important, guys, in AP Calc. Sorry, we use them a lot. But we'll be doing a lot of review throughout the year, so don't worry. All right, so this next one, these are the gross ones. I don't even think I did this in Algebra 2. I might have. Some years I do it, some years I skip it. So are we ready for it? This is the weird one. So 7 and 5, can we get them to be the same base? Nope. And they both have exponents, right? So it's kind of gross. So we're going to do natural log of both sides. So I'm going to have natural log of 7 to the x equals natural log of 5 to the 3x minus 1. And we can pull those powers to the front. So this power goes to the front, and this power goes to the front. So we have x multiplied by natural log of 7, and then we have 3x minus 1 multiplied by natural log of 5. So put that 3x minus 1 in parentheses. So you know the whole thing's multiplied by natural log of 5. Okay, natural log of 7 and natural log of 5 are numbers. So sometimes I teach it by actually writing out what those are as decimals. Okay, but I said I want exact answers. So we're going to go with this, with these numbers. Okay, so we could distribute now as it is, or you can divide the natural log of 5 over. It doesn't matter what you do. So let's say we go ahead and distribute. So we have x times natural log of 7 equals 3 times natural log of 5 times x minus natural log of 5. So I multiply this natural log of 5 into both things. Okay, so think about normal equations. So what's our step in like a normal equation? What's the next thing we would do? Not factor. Kind of, maybe. Maybe you're leading towards that. But you got to get all the x's on one side together. So like you subtract x, right? So we want to get all the x's together and all the things that are just plain numbers on the other side. So that's what we're going to do here. We're going to get all the x's together. So we're going to have x times natural log of 7 minus 3 times natural log of 5 times x is equal to negative natural log of 5. Okay, so that allows us to do, as Kyle's saying, is to factor the x out. Is that what you're saying? So factor the x out. So I get natural log of 7 minus 3 natural log of 5 equals negative natural log of 5. So how do I get x by itself? So we divide it out. So negative natural log of 5 over natural log of 7 minus 3 natural log of 5. That's a lot. And is this the only way the AP test would write it? No, they would be really mean. So they would do things like they would pull this power up 5 cubed is 125. They would combine those natural logs in the bottom. So they would do like negative natural log of 5 over natural log of 7 divided by 125. Like weird things like that.
So you have to.
No. I'm just warning you that this can happen. So remember, it's like a multiple choice test. So your answer might look completely different than their answer. And you got to figure out how they're equivalent. It's kind of annoying. I usually do process of elimination. Like, it's not this one, it's not this one. How could it possibly be this one? All right, so yeah, so that would be that answer. I think on your homework, I let you round to 3 decimals. Isn't that nice of me?
Yes.
Yeah. So negative natural log of 5 divided by natural log of 7 divided by 125. So I think you should get 0.558, and you would have gotten that if you had done it like anywhere along here. Like you could have done it from here and so on. You get the same thing. Oops. All right. So next up. So do you guys want to try these ones first? So try them, see if you can combine, simplify, see if you get the same thing. All right, so as I was walking around, most of you guys were getting it right. Good. So you combine with multiplication this time, right? So it's going to be the x minus 1 multiplied by the x plus 3 because we had a plus right here. So we multiply it out, so FOIL it out, and you get x squared minus, plus 2x minus 3 equals 5. And then we do 2 to the 5th when we switch forms. So we have 2 to the 5th equals x squared plus 2x minus 3. And 2 to the 5th is 32. So we have x squared plus 2x, and we have minus 3 and then minus 32. So minus 35, which factors into x minus 5 times x plus 7. So you get 2 answers, negative 7 and 5. So when you go back to look at your original and you put in negative 7, you have negative 7 minus 1 there, which becomes negative 8, and you can't do log base 2 of a negative number. So if you think about it, if you have log base 2 of negative 8 equals x, can you say 2 to the x equals a negative number? No, it doesn't work. That's why we can't do the log of a negative. So the negative one's out, and then the 5 does work. So 5 is your answer. Good. You guys remembered a lot. I was impressed. You guys remembered your logarithms. Good job. All right, so the next one, so we're going to combine. So we have log base 2. We have 2 over 3, and we're going to multiply by 3 over 32. And this is equal to log base 4 of x. So it's kind of scary because they have different bases. But don't let that throw you. So the 3's go away. The 2 and the 32 reduce out. So we get 16 there. So we have log base 2 of 1 over 16 equals log base 4 of x. So basically this log base 2 of 1 over 16, that's a number, and we should know what that number is. Okay, so what we're saying is 2 raised to some power gives me 1 over 16. So 2 raised to something equals 1 over 16. So what's going to create the 1 over? A negative exponent, right? What about the 16, the bottom part? 4. So it should be negative 4. So all of this is negative 4 equals log base 4 of x. So when we switch forms, we get 4 to the negative 4 equals x. Ooh, 4 to the negative 4. What is 4 to the negative 4? It's 1 over something, right? 4 to the 4. Do you guys know 4 to the 4? I think it's 256. Is it 256? Yeah. So 1 over 256. Oh, the random math facts in my head. I don't know why I used 4 to the 4. 4 to the negative 4 because you're going to switch forms. So you're going to do 4 to the negative 4. It's just on opposite sides this time. Okay. So it says solve the equations on using a graph on a graphing calculator. Give answers as decimals rounded to 3 decimal places. I'm guessing it says to 3 decimal places. All right, so we have 3x cubed minus x minus 4. Okay, so the AP test is not going to ask you how to graph this by hand, like 3x cubed, maybe 3x squared you might need to know how to do, but 3x cubed, that's a little weird. So we're going to go ahead and graph on our graphing calculator. So pull that up. So under y equal, we're going to put 3x cubed. minus x minus 4, and we hit graph. So we're going to get a cubic function. We should know the basic shape of it, right? And we're trying to find when it's equal to 0. So what does that mean in words? Equals 0. What's it mean for our graph? Yeah, not y-intercept, x-intercept, right? We're trying to find the x-intercept. Also known as zeros or roots, right? So we're trying to find the 0. So we have this graph. We want to find this answer right here. So we're going to do second trace and 0. And we're going to get on the left side of the 0 and hit enter, and we're going to get on the right side of the 0 and hit enter. And then guess, just get to whichever one's closer, it doesn't matter. So I got 1.201. Did you guys get 1.201? Awesome. Okay, are there any other answers? No, because this is a cubic function. We know that it doesn't come back down or anything. We know a basic shape of the cubic function is that little like snake shape, right? So we're good. All right, so the next one. So x cubed minus 4x squared plus 5x minus 1. So again, it's x cubed. So we have to have at least one answer. We could have up to 3 answers, right? So we're going to put that in. So I'm going to do x raised to the 3 minus 4x to the 2 plus 5x minus 1. And I hit graph. Okay, so this one also only has one answer. So we're going to find it. So we're going to do second trace, and we're going to find the 0, number 2. So we get on the left of where we think it is, and on the right of where we think it is, and then we go to where we think it is. The guess isn't really too important. Like usually guess, you can just hit enter again wherever you are, unless there's a lot that are really close to each other. So I got 0.245. Did we get 0.245? Yep, so that's our answer. Easy enough? Don't you wish that every single one used the calculator? All right, so how about something like this? So you can do it the way we just did and set everything equal to 0 by subtracting the 3x over, right? So you could do 2x squared minus 1 minus 3x, or 3 to the x equals 0. So that would be totally fine. So if you want to do that, go for it. But there is some convenience in learning what's called the intersect method. So eventually in calculus, we're going to have like curves intersecting. So maybe we have these two curves intersecting and we get this piece. And then we're going to flip it around the axis. We're going to rotate it around and we're going to create these what we call solids of revolution. So for those of you that ever use the wheel, you use the wheel, right, in art class? You'll know what I'm talking about, because as you whip it around and as you adjust it with like a pencil or something and you're trying to make these shapes, we're going to have some different things. So what will be important is finding those intersection points while just leaving them as separate graphs. Okay, this is way in your future. This is like the end of the year stuff. Okay, so sometimes we might need to find the intersection point. So then I would put them in for y1 and y2. Okay, I'm going to pause here so you guys can go on your break though. All right, so we're going to go ahead and put this in for y1 and y2. I don't know why my graphing calculator is not working. Oops. So 2x squared minus 1 for the first one, and then the second one is 3x, or 3 to the x. Can you guys close that door, please? All right, so hit graph. All right, we're going to find the intersection points. So up here, it's kind of hard to tell whether or not those are intersecting, so you might want to adjust your window. So we don't need it to go down as far as it's going, so we could start at like -2, but maybe go up to like 20. And then maybe make the x-axis get a little bit closer, so like maybe to 5 or 6. We'll do 6. So we can really tell if these are intersecting. So it's drawing the quadratic function first, and then it's going to draw the exponential function. And do you see how the exponential function is always going to be greater? It's always going to be above that. So it's really only crossing in one place, which is over here, which is kind of hard to see since I put it at -2, so maybe I'll make it go down to -5 or something. So we have our quadratic and then the exponential, and it's going to intersect somewhere in here. Okay, so let's find it. So we're going to do second, trace, and instead of doing 0, we're going to do intersect. So number 5. And when you do intersect, you basically just want to get on top of it with the first curve and on top of it with the second curve and then guess. So usually it's going to be in that same place all 3 times. So you just hit enter, enter, enter. Yeah. What do I have what?
Like, what do you have plugged in for the graph?
I put both of those graphs. So I put 2x squared minus 1 and I put 3 to the x. So like the left side of the equation and the right side of the equation.
Would it not be
Can you not plug in
You could do minus 3x equals 0. If you do that, then you're going to find the 0 if you did that. Okay, whoops, now I just lost my intersect point. Did you guys have it? What was it? Maybe, actually, I can get it again because I can go back to my main screen, and if I hit X, it will give it to me. Did you guys get negative 0.979? Did you guys get that? Yes? No? No? So maybe that wasn't maybe I didn't finish it. Okay, so second, trace, intersect. So 5. First curve, second curve, guess. Oh, negative, I guess I didn't do the last enter. So negative 0.836. Okay, so it's convenient to know both methods though, and that's what I was kind of telling you before break. Okay, so something like this. So this is a logarithm and a trig function. So like, how would you solve this, right? So we would use a calculator to solve it. There are advanced math ways of solving that. Using polynomials, you can make these look like polynomials, which is kind of crazy, but it's still just an approximation method. So calculator is totally fine. Okay, so we're going to do 2 times log of x plus 1. So I'm going to put that in for y1, and then I'm going to put 4 times cosine of x. Okay, and this one gives me a domain, so it says on 0 to 2 pi, which makes sense because it's a cosine function, right? So I'm going to do window, and I'm going to put my x min as 0 and my x max as 2 pi, and you can use the pi button. So when you hit enter or push down, it will do 6.283. All right, so we're going to hit graph. So it's doing the log function first, and then it's doing the cosine function. So it looks like it's intersecting in 2 different places. So we're going to find both of those answers. So we do second, trace, intersect. And we just trace along the first curve until we get to the place where we think it intersects. And when you hit enter, it kind of goes to that same spot. So as long as you're close, hit enter again and then guess. So we get 1.381 for the first one. So write that one down, 1.381. And then we do our second one. So we go intersect again, and we go to the other location. So we get x equals 1.381 was the first one, and then x equals 5.117 for the second one. Did you guys get those numbers? All right, so now we have things where it says like less than 0, greater than or equal to 0. You can do inequalities on your calculators, but I'm not going to do the inequalities. We're just going to think logically about what this means. Okay, so we're going to put x to the 4th, that function, in for our y1. So go to y1. I'm going to clear both these out. So I'm putting x raised to the 4 minus 2x to the 3. Plus 3x to the 2 minus 2. Okay. And I'm going to hit graph. Oh, so I need to adjust my window, don't I? So if I need to go back to my standard window, I can always do zoom. So hit zoom, and you guys see 6, it's zoom standard. That's the negative 10 to 10 window. That's always a good one to start with, right? Okay, and we know that our x to the 4th graphs can look like a parabola, or they can look like the w's. When they're w's, it's usually because you have a minus x squared in it. So see how this is a plus x squared? So it's probably just like a U shape. Okay, so we have these 2 intersection points. We want to find where it's smaller than 0. Yeah, we're going to find those intersect those intersection points with the y-axis, so the intercepts. And then what are we going to do? Is it going to be this side and this side, or is it going to be in between? And tell me why. It's like critical values that we were doing the other day. Okay, this is like our y1. This is kind of like y2. y2 is equal to 0. So we have a graph, and we're saying, where is this graph smaller than the line y equals 0? Where is it smaller? From here to here. That's what we're saying. Does that make sense? So we want to find those two intersection points, and then we're going to put it on an interval. So we're going to say it's between that intersection point and that intersection point. So it's going to be here to here. It's on an interval. Does that make sense? So we're going to do a second trace intersect. We're going to get on the left of our 0 and on the right side of the 0. I can tell I'm on the right side because my y is negative now. Hit enter. Oh, whoops, I forgot. I did intersection, didn't I? So second trace, it's saying second curve, and I don't have a second curve. 0. Sorry about that. So left bound, right bound, enter. So did you guys get negative 0.651? Okay. And you could have 650 if you want. I just feel like it's weird. All right, and then right bound. So we get on the left side, and then we get on the right side. And then guess. So it looks like 1. That was nice. So negative 0.651 comma 1. Make sense? All right, so this last one says, well, when is it greater than or equal to 0? So putting this in for y1 can be tricky. You have to put parentheses around the numerator and the denominator, unless you guys have what I call fancy font on your calculator. Do you know what I mean by that? Where it's actually making a numerator and making a denominator. You're going to need to put those parentheses in if you don't. Okay. So here we go. So we do parentheses x squared plus 3x minus 2, parentheses, and we're dividing by parentheses x plus 4. Some of you guys not have calculators. So we hit graph. We get something that has a slant asymptote, because it's 1 degree higher on top than bottom. So we have this weird graph. And we're finding when it's greater than or equal to 0. So we want to find these, whoops, I don't know what I did there. We want to find these 2 points. I'm trying to click on it, but it's not letting me. The 2 intersection points. Can I like drag it? Oh, that's so cool. I didn't even know I could do that. Must have been an upgrade. So we want to find these. How fancy. You guys wish you could do that. Okay, so second trace. We're finding the zeros. So left bound, right bound, enter. So it looks like 0.562. All right, and then find the other one. So negative 0.3562. 3.562. Sorry, I said that wrong, didn't I? Now we want to know where it's greater than or equal to 0. So what do you guys think we're going to write for interval notation on this one? 0.562 to infinity. Ah, 10. He's saying 10. Why does he say 10? Yeah, look at it. We're only on the interval 0 to 10. So we're stopping at 10. And we do a parenthesis because 10 wasn't included. What about the other side? Anything? Negative infinity to negative 3.562? No, because it's not on the interval that we were given. Does that make sense? So that's our final solution. Good. All right, so let's stop there.